From our 3 investigations deriving the formula for area of a circle, we used the licorice that we saw a circle turns into a triangle. We used a circle inscribed in a square, and we used that the circle we could cut into smaller triangles to make a parallelogram. So just to do a quick recap of this one, if we had one of these squares, the area is A equals R times R, because the length of the square is really the radius of our circle, so it's area equals radius squared. And if we were to fill in this whole circle, it would take us just over 3, and again there's that magic number 3. So just over 3 of these, which is our pi, 3.14. And that's where we get our formula for area of a circle. How do we use it? Well, again, it comes down to choosing the right formula and plugging in the right variables. So if we were given that the radius is 4, we have, again, we start with our formula. Area equals pi r squared. You could write pi again or 3.14, it doesn't matter. Times 4, and 4 is squared. And this is where we have to remember that 4 squared is not 8, it is really 4 times 4. So you have 3.14, and I'll write it down for this time, you don't have to write it every single time. 4.14 times 16. But because this, for most of us, this is all calculator work, you could have gone straight from line 1, line 2, and line 3. So let's see what the calculator says. 3.14 times 16 is 50.24. And because our radius is squared, it's going to be meters squared. And that's it for finding area. If we were given the diameter, so let's say we were given D equals 12, we have to do 2 steps. You have to first find the radius, but you know that radius is half of diameter. Again, showing my formula, showing the numbers that I'm plugging in. You need to get in the habit of this because when we do word problems and they're multi-step, you have to show all these steps. And now we have our area is pi r squared. Area is 3.14 times 6 squared. So I'm going to go right to the calculator on that one, and I have 3.14 times 6 times 6, or I could have done times 36, 113.04. So at this step, you should be trying these on your calculator as well to make sure you're getting the same answer and you understand how your calculator functions, because some of them, if you're using the exponent button, you may find different orders that you have to type it in, but it's important to make sure that you're working along with these questions and not just staring at the screen listening to me. Okay? The tricky part is how do we work backwards? What happens if we know the full inside area, but I want to know how far is it if I have a dog that's attached to my leash that goes from the center or the corner of my house and he's out here. What's his radius? What's the chain link that goes from my house here out here? What's his distance going to be if I know that there's an area of, let's say, 42? And that one's going to be really small, but that's okay. So let's say we have a circle that has an area of 42 meters squared, and I want to know what my radius of that circle is. Well, I know what formula has both area and radius in it, so I have to start there. And this goes with what we were talking about in video 2 of circumference. I need to get the radius by itself. I need to isolate the variable. So what's 3.14 divided by 3.14? Well, it's 1, so it cancels out. So now I know that those are going to cancel because they're worth 1. and I can say that radius squared equals area divided by pi. And we'll do it this way, we'll plug all our variables in. The catch is we still have to deal with this exponent. There's still the x squared. So area is 42 divided by 3.14. And we have our radius squared is 42 divided by 3.14, 13.38. Remember those roundings. 13.38. Now this is still meters squared because we took area, which is squared, and we divided by a constant. We divided by 13.14. So nothing has changed with my units of meters squared. But we have a squared on this side that we get rid of. What's the opposite of squaring something? How do we get rid of a square root? Or sorry, a square? Well, we have to take the square root. So the square root of this will cancel out that 2, and the square root of this will give us the side length, and it cancels out those meters. So we just will have radius equals, so think about that, 13 is that whole inside of this square, and it will, when we square root it, it will just give me that one single r. And calculator, so 13.38 square root 3.66. And now we have our meters, because it's just a length. It's a single dimension. So if they wanted diameter at this point, what would you do? Radius equals, or sorry, diameter equals radius times 2. And that's it.